So great. I'm glad you're here in the office hour.
Mhm. Yeah, I thought I usually don't come to these things, but I thought I might as well, just see what's going on.
I appreciate that.
Okay, so you said chapter 1.4, right?
Section 1.4. So I'm going to try to look at it. I'm going to try to look at it like you would be looking at it.
Okay.
Okay, yeah. So there's like 12 questions.
So are we moving over to all assignments being
I
my?
think so. I want to get some feedback from y'all tomorrow,
Okay.
during class, like a straw poll. But man, it took me 10 hours to grade the first homework.
Mm,
And I did not even grade every problem. I just, graded some of the problems.
mm.
So it is definitely possible that we'll be doing this. We're gonna, I'm playing it by ear. But
Okay.
since it's free,
Yeah, might as well.
and I've got some, like on this very first problem in section 1.4, when you click on it,
Mm,
I've added these tips,
mm.
I amended the day 3 class notes on page 8. I added in writing what I pointed out verbally at the very end of lecture. And that was how to use the row vector method for computing AX. We also went over that at the very beginning of day 4. Like we did another problem in day 4.
Yeah, I remember.
So that's what this problem is about. It's about computing this product 2 different ways.
Okay. Since our values are different, should I share my screen?
Yeah, it's going to be the same idea, but yeah, why don't you go ahead? I'll stop sharing and you share your screen.
Okay.
Great. All right. So why don't you read the directions for part A and we'll think about that.
Mhm.
So it starts off, compute the product using the methods below. If a product's undefined, explain why. So part A.
Yeah. So hold on.
What do the instructions say?
X is this vector of ones, right? And
Yeah, that makes it easy.
the definition where linear combination of the columns of A using the corresponding entries in X as weights. Select the correct choice below, and if necessary, fill the answer boxes to complete your choice. So it would be, right, like X1 times A1. Wait, but shouldn't A have more indices?
Well, see, they've given you a choice between, so I would always work these with pencil and paper, right? So like I would write down 7, 5. Oh, sorry, 7, not, let me, hang on, let me get a white out, let me get a darker pen, not a green pen. Okay, so like always use paper and pencil when you're working. So, you can figure out whether does it look like it's defined to you? Does it look like the number of columns of A is going to be correct for that particular vector X?
Yes.
Yeah, it does to me too. So the question is, okay, we've got 2 answers that say it's defined. The question is it going to be answer A or answer B, right? So to figure out if it's answer A or answer B, we have to carefully read those answers, okay? So the first answer says it's going to be X1 times A1, where A1 is bold. That means it's a vector, plus X2, A2, plus X3, A3. And when I think about this, right, like, can you see what I'm doing here? I know this first coordinate is going to weight the first column, right? So it would be 1 times the first column, and that's what they're calling A1. Plus, right? Because, X1 is 1 and X2 is 1. So I can see right now I'm going to need 3 columns multiplied times 3 coordinates, right? So that's So the first thing to do is just to figure out, hey, am I going to be filling out part A because it's got the right number of, you know, coordinates times columns, or is part B the one that's got the correct number of coordinates times columns? You see what I'm saying? Like they're already kind of setting you up to realize, oh, I'm going to need 3 summands. A summand is, things that get added together. I'm going to need 3 products being added together, where it's always the coefficient times the column. Right. So right away you're going to click A. So I think the first thing you do is click A, and then the editor is going to pop. All right. So you'll put in just the number 1, right? And now you're going to put in a matrix. So if you go down to that little equation editor, right? Yeah. No, I think the one, yeah. And you can pick a size, number of rows times number of columns. I think you're going to need 3 rows though. Oh, no, you're right. Only 2, because these vectors are only 2 bys. You're right. You're right. Good for you. Yes. Yes. See, you're smarter than I am.
I don't know about all that.
Yeah, but look at you. You're navigating that just perfectly. And if you ever get stuck, you can like do show me, and yeah, click it and then check your answer. See, nice job. Okay, cool.
I have a question. Just to clarify how we would get the linear combination, right? With so like when you do 7 times 1, oh, you would get a 2 by matrix.
Yeah, because you're going to be right. Like we can go ahead and calculate the actual answer, and I think part C, you actually calculate the answer where, on your paper, you actually go ahead and multiply this out.
Okay, I got it. I was just trying to figure out how we correlate the second row of the matrix with the coefficient when we're actually calculating the linear combination. But
Yeah, well, the 1 gets multiplied by both coordinates. That's what it means to multiply a vector by a scalar. Every coordinate gets multiplied by that vector. And this one's kind of silly because it's getting multiplied by 1 every time.
Yeah.
Now, set up the product using the row vector rule. Now, that's different. But you're right in that it's going to be a 2 by 1.
Okay.
So now you may need to refer to notes, or I can just remind you how that works. You want me to just remind you how that works?
I think I remember. It'll be I mean, in this case, it's kind of like hard, right? But like 7 times the first one plus 5 times the first one plus minus 4 times the first one. Oh, no, 7 times the first one plus 5 times the second one plus minus 4 times the third one.
Yeah. So it'll be something like, this for the first one, where you put, parentheses and pluses or minuses. And I'm sure that it'll accept it whether you put -4 or plus a -4. It should accept it either way, right?
Simplify.
And it shouldn't matter which you put first. It shouldn't matter if you put the row value first or the vector value first. See what I mean? Right. Yeah, it should be fairly lenient. But yeah, you got the idea. You've got exactly the right idea. I don't know if it's going to want parentheses around that -4 or not. It may not need them since you put the times. I just don't know.
Yeah.
But that's you get like 3 tries, so that should work fine. And in fact, you probably did not even need the parentheses since you put a times sign.
Well, better safe than sorry with these things.
Oh, you got that right. Parentheses are your friends.
Yeah. Okay.
All right, let's.
Nice.
Haha, it likes. Nice. And then it says simplify your answer. And that's where you actually perform the calculation to make the final answer, which is B. You're finding the B that gets hit when you weight those columns.
Okay, cool. That was simple enough. Report. Okay.
You don't need the instructor tip. You just clicked on the instructor tip without reading it. Oh, how did you find?
Only if the inside numbers are equal, yeah. Okay. So we're gonna get to the same answer both ways, but they just won. What?
If it's defined,
If it's
you got to
defined.
read the whole problem.
Yeah.
Compute the product. If a product is defined, undefined, explain why. Is it the number of rows in matrix A that has to match the number of entries in vector X, or is it the number of columns in matrix A that has to?
Columns.
See, yeah, you got to actually read, yeah.
Yeah.
Yeah, you're moving right along.
Mhm. A matrix equation, is that just one long line?
A
Is it-
matrix equation, this is what, number 3, looks like AX equals B. So you'll have a matrix times an X equals a vector B. So you got to figure out how big the coefficient matrix A is going to be, B. Yeah, it's 2 by 4, exactly. And you see the columns are there. So yeah, exactly. So you just put those values into the perfect. Look at you go. Look at you go. Nice. All right, so that's the A. And then you want to multiply it times an X.
Which will have one column and
That's right. That's right, because it's always a vector.
I have to do this one.
Yep, exactly. You're using the editor exactly right to put those subscripts in. Looks like you've used a math editor before.
Mhm.
Where'd you go to high school?
I went to boarding school in Switzerland.
Oh my God.
Yeah.
Oh my God. So can I, so I like, I bow to you. Lucky you, man.
No, I know. It's yeah.
I hope it was good for you. I mean, I hope, so the great thing is being in Europe,
Mhm.
because it's really different from the States, right? Like people have a little more culture and a little more reserve and a little more political savvy,
Yeah, yeah.
right? Discourse is a little higher level
I
at
think so.
at the dinner table, right?
Mm.
Lucky you, man.
Yeah. Oh, yeah. A great 2 years. I did the IB program, if you're familiar.
I'm not, spell it.
IB, so like just IB, it's an abbreviation for International Baccalaureate.
Okay.
Yeah.
Is that something that you look to do, or your parents knew about it, or your guidance counselor from an earlier high school, or?
No, it was just what was available at the school, so I chose. I just did it. It's similar to AP.
Okay. All
But
right. That makes, okay. So it corresponds to American AP.
kind of loosely.
So, I guess it was an English speaking boarding school, not
Yeah, yeah. It was
German.
actually an American boarding school, but they also offered the IB program.
Uh-huh. So did you do you speak another language as well?
A little bit of French.
A little
Uh,
French.
mhm. Do you speak another language?
Well, bisschen. The father of my children is German.
Mm.
So I learned a little German, speak a little Spanish, I speak a little Italian,
Mm.
just enough to say, hey, where is it and how much does it cost? And, what time does the train get here? And,
Mm.
where am I? Where's the bathroom? Stuff like that.
Yeah, yeah. So have you been to either of those places, Italy, Germany?
Oh, absolutely. Yeah. I traveled a lot when I was a young woman.
Mm.
I was a bicycler. I did a lot of international bicycling.
Oh wow. So I heard that there's this place in Spain. Like I heard the Spanish are getting very tired because it's a hot spot for bicycle tourism.
Is that right?
Yeah, there's like yeah, in Barcelona they were like spraying cyclists with water guns.
No.
Yeah,
Well, yeah, yeah. We landed in the Netherlands, and that's like God's country for biking. It's flat.
yeah.
They even have like lanes in the streets that
Mm,
are have little stop go lights
mm,
for bicyclers and yeah, I bicycled all through Scandinavia, and then I took a boat down into Poland and bicycled through the Eastern Bloc countries before the wall fell.
mm,
This was the early 80s before the wall fell, when it was still, Soviet Union
yeah.
countries. And it was really exciting and interesting to visit those people in those countries.
You like pierogi?
Yeah, I like pierogi, okay.
Yeah.
You know, I mean, it's not my favorite food in dough. There are lots of different foods that, come wrapped up in dough. I think my favorite is more of the Chinese steamed dumplings, but pierogi are delicious.
Mm,
They are good.
mm.
So what's going on with this one? You said, do you like pierogi?
I do. Yeah.
Do
Very
you
much.
make them?
No, never. I just buy them prepackaged, or I had them because one of my friends is Polish.
Nice.
Mhm.
So
All right.
now that is being presented as just a system of linear equations,
Yeah,
and
yeah.
you're asked to write it as a vector equation first, and then as,
Okay, so this one, C would be the vector equation.
that's right. Wait, yeah, the vector equation where you're weighting the vector columns.
Wait, that's not right. This is not right.
Yeah, you need it a little bit bigger.
Yeah.
Oh, you have to actually delete it. You can't just edit it on the fly. Okay.
Maybe you can if you click this button.
Well, you're a privileged young man. I'm
Yeah.
sure you realize that.
Mhm. Yeah.
Bravo. Hey, maybe somebody is.
Bruh.
Well, that's frustrating. Nice. Perfect. This is great. I can just watch you.
Mm. Oh, well, yes, 3 by 1 it would become.
So take a look at the size of your matrix A. Is it the right size to multiply times the 2 by 1 vector?
No.
So what's going wrong there?
Let me think. Let me think. Oh,
You've given the augmented matrix,
yeah,
but all you need is the coefficient matrix.
yeah. Um,
And unfortunately, I wonder if you could copy and paste those first two columns without retyping. Nah, it's not gonna let you. Is it a smart copy and paste where you wouldn't have to retype those? Nice.
wait, okay.
Oh, nice. Did it work?
No, I had to select the column.
Got to select the column to delete.
Yeah,
Nice. I think that fixes it.
yeah.
Oh, that's a nice thing to realize though, that you don't have to retype the whole daggum thing.
Mhm.
you're making the same mistake you made a minute ago.
But it said to write the augmented matrix.
That right, AX equals B. So you're right. The course. Sorry. Yeah. Okay. Yeah. You're right. You're right. You're right. That corresponds to the matrix equation. And yeah. So yep. Even Dr. Good's got to read it carefully. And then
Now I have to work on paper.
now you got to actually work on it. Yeah. And while you will need to have to, you will have to do some row operations on test one, it is okay to use a calculator at this stage.
Hmm.
I mean, there's only so many row operations a person wants to do in their lifetime, right?
Yeah. Okay, wait. Oh, simple.
It'd be nice if this thing had a built-in row reduction calculator, wouldn't it?
It would.
Wouldn't that be a smart little GUI?
It would. It would. Do you think it does?
No.
No. Have you played with it?
Yeah.
Okay.
But it might be possible to find an online calculator where you could cut and paste this into a matrix function. That I haven't fully explored. I have not found one online where you could just copy and paste into an online calculator and then hit RREF. But there may be one. If you find one, I'll give you extra credit for giving me a link. I mean, just that, we can do that later. But yeah, there's gotta be one somewhere online where you can cut and paste. Cutting and pasting from one app to another app can be a little sticky though, right? I mean, that's actually kind of a classic IT problem. Scraping data, using cut and paste editor. It's kind of a classic GUI problem.
Yeah, Decimals apparently has I don't know if you can cut and paste, but they have a matrix calculator.
What's that?
Desmos?
Spell it.
No, Desmos, like they have the scientific calculator and the graphing calculator. It's pretty popular. EESMOS.
I'm gonna look it up. Desmos has a beautiful free math scientific calculator. Let's see if it's got a matrix function. Nope. Let me go back and see what else they've got. Graphing calculator, geometry, more results from Desmos. Let's see. I think I'll just search Desmos matrix calculator.
Yeah, I can send you the link as well.
Oh, you found it already?
Yeah.
Oh yeah, there it is, matrix calculator. Okay, new matrix. Edit the rows and all right, so I'm gonna actually see if I can cut and paste from this. No, I can't cut and paste from this screen.
Yeah.
Is it cutting and pasting for you though?
No, I don't. Maybe I wasn't grabbing it correctly. I can try again, but it didn't seem to be working.
Like I said, I mean, I don't want to discourage you. Definitely try it. But this is a classic kind of issue when you're trying to grab from one app to another app.
Yeah.
Because the coding is not always
different, right? Like,
right. I mean, there needs to be like a USB, version of the code for such things, right? You know what I mean? Like a standard.
I don't know what USB means. I know universal.
Universal standard bus.
Yeah.
So it's supposedly any machine should be able to plug with a converter through a USB port. like PDF is like this kind of a standard in visual processing. You should be able to convert anything to a PDF, like
Mhm,
a JPEG or a TIFF or whatever, or a PostScript,
mhm,
whatever program you're using that generates a visual image. That image should be convertible to a PDF. In some sense, it's the standard for visual processing.
mhm,
So the USB is the hardware standard for plugging hardware into other hardware, like, peripheral devices into hardware.
mhm,
So,
mhm,
I mean, that problem was solved with the USB port.
mhm,
And I mean, the HDMI ports, they carry more data, right? I mean, so like for 4D, 4HD, and higher visual, they use HDMI ports. But the point was somebody figured out we need a hardware standard.
mhm,
And this standard for cutting and pasting, um, for creating text that's embedded with formatting, that's what this is. It's formatted text. There's
mhm,
so many different ways to generate that kind of text
mhm,
that, like for mathematicians, the standard way I would create a matrix is using a typesetting program called LaTeX or LaTeX or Tech, TEX.
Somewhere online I've seen that, but I really don't know what it is.
It's what I use to typeset everything that you see me type. You don't see me type that much yet,
Mhm,
but it's a typesetting program. It's not a word processor. See, that's the other way you can create these kinds of visual arrays. You can use something like, Word
mhm,
or Open Office, right? They also, any kind of equation editor can create a matrix. Uh-oh, let's see. So you row reduced it. It says
mhm.
how many rows contain that's not reduced yet. So did you row reduce it?
Yeah, I can share my screen. Maybe I entered something wrong. I'm just gonna.
Yeah, double check that.
Can you see here? I'll just try and hide this somewhere. I don't know.
Well, there are 3 rows that contain pivot positions according to your result: row 1, row 2, and row 3. You see, even though that 1 is sort of naughty there in that 3rd row, it is still technically a pivot position because it's the first non-zero entry in that row.
We haven't been told that this is an augmented matrix, right? If it was an augmented matrix, then it would not be a pivot position. Or would
No,
it?
it can be. It
It-
can be. Even in all, and in fact, I've graded your homework, and if you missed that, I probably corrected you. By definition, whether you're looking at a coefficient matrix A or an augmented matrix, okay,
Mm,
every first non-zero entry in a given row is by definition a pivot position, whether that happens to be the row for the vector B on the other side of the equation in an augmented matrix, or whether it's a coefficient matrix, okay? And in fact, getting a pivot in that rightmost row of a reduced augmented matrix is exactly what it means to have a system that's inconsistent and has no solution.
in the last row?
Yeah, well, I mean, in the last column, did I say row? In the rightmost column, if it's an augmented matrix, okay, that rightmost column started out as that vector B on the other side of the equal sign, right? On the right side of the equality. So the point is, it doesn't really matter whether A is augmented or not. By definition, you've got 3 pivot positions there.
Mhm.
Okay, so by definition, the pivot position is the first non-zero entry in a given row. So you have 3 such non-zero entries. They're all ones there.
Mhm.
You don't really know how, so it does look like this is being used as a coefficient matrix because later it says, does AX equal B have a solution for each B? So
Yeah.
that is a coefficient matrix.
Yeah.
So in this case, you've got what? You've got X1, X2, X3, and X4. So you got 4 variables, right? One labeling each column. And X3 looks like a free variable because it has no pivot.
Mhm. And then I need to look, does it have a solution for each B?
Well,
Uh,
B is going to be a vector, not a matrix.
yeah. I mean,
Little b, okay?
Yeah.
Big B there is what the book calls U, like in your calculator, in your Desmos calculator. You put it in as B, that's fine. Okay. But yeah, little b is that vector on the other side of the equation. Am I answering your question properly? Or
Uh,
am I just confusing you?
a little bit, because there's something that we said, we're talking about span, right?
Okay, yeah,
And we were saying that,
okay. So they are giving you a coefficient matrix because of the context, okay? Do you understand that?
yes,
All
yeah,
right, so they're giving
yeah.
a coefficient matrix A, and they're asking, you know, does AX equal B have a solution for each B in, well, what's the size of B? It's going to be in R4 because it'd be a linear combination of those columns, right?
Mm.
All right, so the deal is when you row reduced A, you got, what is it? It's 4 by 4. I won't write the entries, but I can, in red, you got pivots in columns and row. You got a pivot here, right? You got a pivot here, and you got a pivot here.
Mhm.
So x1 is a basic variable, it has a pivot. X2 is a basic variable, it has a pivot, but x3 is free.
Mhm.
X4 is basic. But the
Mhm.
point is, this is A in row reduced form. So that means those pivot positions are exactly the same in the original matrix, okay?
Mhm.
And because there is not a pivot in every row of the coefficient matrix A, okay, we only have these 3 pivot positions.
Mhm.
That theorem 4 says, hey, these columns do not span
Mhm.
R4. They'll give you some of the vectors in R4, but there will be some vectors in R4 that you cannot achieve by linear combinations of these columns.
Yeah.
Because what it means is that this variable x3 is actually something that you can write the other variables in terms of.
Mhm.
So this freedom actually reduces the set of vectors B that you can hit as linear combinations. Like if you think of the matrix A being applied to X as sort of like stringing an arrow into a bow and shooting it toward R4, this matrix A is special. It's a special bow. It can only hit certain things in R4. It can't hit everything
Mm.
because you would need a pivot in every single of these 4 rows, which would make this having no free variables.
Mhm.
Now this is square, and that's the other thing that happens that confuses things. Depending upon whether the coefficient matrix is square or not, things look, a little different, but and then you have to think about how many variables you're really dealing with. That theorem works because the sizes of X and A and B in the theorem work out to force A to be square.
Mm. Okay. Okay. I see.
There's a lot going on there, but we'll try to kind of, hit it from different angles.
Mm.
See, that's the theorem 4 that was so important.
Mm.
I
So
know it's a pain in the butt, but you know what? I wrote theorem 4. I
yeah,
wrote theorem 4 in the notes.
they're logically equivalent.
Yeah, it means if one of those happens, all the other ones happen. If one of those is false, then they're all false.
Columns of A span. Okay.
So it's false. It is not true that every row of the coefficient matrix A has a pivot.
Oh, it's for that's for the one we were just working on, right?
Yep. I was just completing these notes. I'll scan these and post them. And this video, you've just helped a bunch of people. Thank you very much.
No, it does not span R4 because X4 is from, oh, okay, so now I have to write it in the reduced echelon form. So that means this one that they're looking at.
Yes.
Mm,
Oh, yeah. And can you math frac that? You're going to want to put, you're not going to want to use decimals because they're approximately, there you go. Exactly. You always want to use an exact answer.
mhm.
You know, when there's a choice, exact is what we always shoot for in mathematics. So decimal expansions, that's why defining a rational number as a decimal expansion that eventually repeats is kind of, in my opinion, sort of the less than ideal definition for a rational number. The better definition is that it can be written as a quotient of integers with a non-zero denominator, like you're doing right now. Quotients of integers, right? There you go. Oh, snap. What? All right, hang on, let's take a look. Let's just double check your entries in your matrix C. 3, 1, 3, 2, 2, 0, negative 2, 4, 3, 4, 21, negative 10, negative 1, negative 7. There we go. Ho ho! It's even easier. Yeah, these authors shoot for integers whenever possible.
Yeah, so still not.
So you're gonna.
Yes. Why did I hit yes? I meant no.
Oh, well, there's that. There's that too. Good griefs. I didn't even catch that. Yeah. Just got to replace that whole thing. You just got to delete that whole fraction area.
Not that far.
Don't forget your 6. Yeah, there you go. Yeah, it looks like a not too bad editor. Don't forget your, yeah, this is it. There you go. That should work. Ah, fantastic.
No, because they do not span R4.
There you go.
Remember whether the statement below is true or false, justify the answer. Vector B is a linear combination of the columns of a matrix A if and only if it has at least one solution. Yes?
Yes, you telling me or you asking me?
No, I'm saying it's a linear combination if, yeah, because if it has a solution, it is a linear.
Yeah. I mean, that's what that means. That's what having a solution means. It means you can get B by weighting the columns of A somehow. There may, that's right. There may be more than one way to do it, but
yes, I believe this is true. Okay.
nice. Moving right along here.
Solution set of a linear system is augmented matrix with the same the solution set of this if A is equal to this.
Right.
Yes. The statement is true. If A is in with columns, B is a vector Rm. No.
So they're giving you that A is M by N.
Yeah. And
so
then
you got to think about how big the product A times X is going to be. And yes, right, it'll be M by 1, right?
really? Yes,
Well, Because the product is the outer numbers. So if A is M by N, here, let me write this down for you. Remember, this is one of the things I was trying to show you. You have A times X equals B. Okay, so this is what problem number 9. If A is M by N, the only thing you can multiply it by, in terms of a vector, is something by 1, right? Because that's what a vector is. It's some number of rows by 1 column. But you see, these inside numbers have to match. So this has to be n by 1. B, on the other hand, gets its dimensions from the outsides.
M by 1.
So it's m by 1. So, B, if B is m by 1, we say B is an element of Rm. That's what it means. It's got m rows.
Yeah, because like
column vector with m rows. Yeah.
So like if M, because like if you're thinking about it and maybe like a problem that you're trying to solve, right? M is the number of entries that you have. N is the number of features of those entries, right? And then you have this weight, which should print out a result for each of the entries. So it should obviously be as long as the number of entries that you have.
That's right. The columns of A have m entries because it's m rows in A. That's exactly right.
Okay.
Does that make sense? Are we speaking the same language here?
We are, I believe so.
That's good.
Okay, question 10. Determine whether the statement below is true or false. Justify the answer. If A is an M by N matrix, and if the equation AX is equal to B is inconsistent for some B in Rm,
And if the equation is inconsistent,
consistent for some B, then A cannot have a pivot position in every row.
Go back to theorem 4.
And then the correct answer is true if the equation, no. The equation has no solution for some B in Rm.
That's exactly right. And it's really nice because if a student kind of guessed that, and I could tweak this so that you only get like 2 tries on the true false, but I'm trying to just be kind of friendly there. But the nice thing is when you get the right answer, it gives you that little explanation that you closed so quickly. But that can help for a kid that's guessing. Now, you're not supposed to do any row operations here. Read the directions. This is important that you understand what this is saying.
Okay. Let U equal this vector,
Right.
vector, and W is equal to this vector.
That's
It
right.
can be shown that this linear combination equals 0. Use this fact and no operations, to find x1 and x2 that satisfy the equation this. No. Okay. But wait. So they've combined and W. Oh yeah, because like 3U minus 3U minus 4V is equal to W. Yes, that's true.
That's right. They're telling you that -3 times U, in other words, if you weight U with -3, minus 4 times V, then they, geez, Louise, right? They make you, add W to both sides, right?
Yeah.
But it's kind of interesting because when you think about it this way, we're talking about a plane, right? We've got 3 unknowns. That's a plane in, what space we're in R3, I guess there. So, this is asking, when does that plane go through the origin? That's what this is actually asking. Okay, but when we rearrange it, suddenly we've got a linear combination of 2 vectors equaling this vector on the other side, which is the B, which is they're calling W. So you can see the weights right there.
Yeah.
It's kind of nice. I think it's a pretty problem. Because it's a concept problem.
Determine if the columns of the matrix span R4. So I need to do a linear reduction, or is that what it's called? No.
Yeah, a row reduction using elementary row operations. Yeah, row reduction. You can call it linear reduction. I know what you're talking about. By the way, if you can see that, and I don't see this, but if you could see that obviously one column is like a scalar multiple of another column, then it's going to row reduce down to not have a 4 pivots. That's something we're going to be talking about tomorrow more. But there's no obvious column that is a multiple of another column. Sometimes you can subtract one column from another or add 2 columns together and get another column. And you can see, oh yeah, one of these columns is a linear combination of a couple of other columns, but that's not obvious in this particular problem. A row reduction is your correct method of attack. Yeah.
And then you mentioned something. So after I finish this, I have a question for you.
Sure. I hope I have an answer.
Let's do this.
Oh, this is great. So Desmos.com matrix. That rocks, because man, isn't that just easier? I'm gonna add that right now to our website. I'm gonna stick it in the reading page at the top.
Does not have a foot. No. Hope it's right.
Oh, I don't see why I wouldn't be. I'll double check your entries while you're. It looks right to. I mean, the entries are correct. There's no reason why that wouldn't be right. By the way, just FYI, you can detect the pivot columns by performing just a row reduction to echelon form. You don't actually have to do the work all the way to reduced echelon form to identify the pivot positions.
It just says the leading entry in every row.
Yeah, that's right. The first non-zero leading entry, and it doesn't have to be a 1 for you to identify it.
Okay.
And then you don't have to have zeros above the pivot positions. You just have to have the zeros below the pivot positions.
Okay.
Wow. Well, that's perfect timing. We just finished section 1.4 together, and that was really helpful for people.
Yeah, helpful for me too. Thank you.
All right. Well, I'll see you again soon. And you can always request an office hour. I'm around, later in the evenings. If you get stuck on 1.5, we could just email me and we could do a pop-up office hour, later tomorrow night.
Okay, sounds great.
Sometimes even in the morning.
Okay, thank you so much.
So welcome. Bye-bye.